BRDs, okay, and we discussed about what is the dimension table and what is the fact table, okay. And after that, so today we'll discuss about the slowly changing dimension as well as the star schema and the snowflakes schema. Actually, schema is nothing but like here we have as we discussed in the last class, we have a dimension tables, and in the target system, so we are going to load the data in the form of a dimension tables as well as the fact tables. Okay, so like as we know that we discussed with the same, we are going to consider the same target system as a source for the business objects universe. Okay, so on top of that source system, we are going to develop the universe, and on top of, with the help of this universe, we are going to develop the report. Actually, this is what we are doing in the real-time scenarios. So what exactly is the star schema? So here, star schema is nothing but one fact table is surrounded by the multiple dimension tables. Very simple, sir. For example, just for your understanding, just assume that I have a fact table called XYZ fact table. XYZ fact table, and just assume I have a dimension table, employee dimension table, I have a department dimension table, and the calendar dimension table, that is the time dimension, and just assume that there is one more dimension table called student dimension table, for example. So dimension table contains the individual, so it will provide you the individual business first of all, and after that dimension table contains the primary key values, unique key system, right? So for example, for example, I have a student dimension. So what exactly the student dimension contains? Student dimension contains the student ID, student name, one for example, my material value, one what we call the student marks. Okay, these are the three fields. Now coming to the product dimension, for example, product dimension, product ID, product name, and the quantity. And then calendar dimension, like time and dimension, as you know that we have the calendar IDs are available, and one more dimension table, that is the student dimension or the employee dimension, employee ID, employee name, employee salary. Okay, so these are 4 dimension tables I have. So as you know that with the help of this dimension, once we have the if we have the dimension, then only we can able to prepare the fact tables, right? So in the fact table area, what are the columns that can you guess what are the columns are available in the fact table? I have 4 dimensions: employee dimension, student dimension, calendar dimension, that is the time dimension, as well as product dimension. Now with the help of these dimension tables, I just wanted to prepare a fact table. So how can I prepare the fact table? And that means, what are the columns that the fact table contains? Any guess, any idea?
Like the student table can contain student marks, and the employee can have the salary information.
Okay.
The product, for the products, we can have the price ranges in the fact table.
Okay. As I told you that the product table contains the product ID, product name, and the quantity sold.
Okay.
Okay. Any answers, Venkat or Malvika?
Yeah, can be change very often.
Okay.
And the dimension table data can be variable, it can vary frequently.
Yeah, that's what actually. My question is, actually I have 4 dimension tables as I listed out, student dimension and product dimension, time dimension, as well as employee dimension, for example. Now I just wanted to create one fact table, as you know that whatever the primary key is available in the dimension, the same primary key is converted as a foreign key, that is the reference of that particular dimension table in the fact table area, right?
Yeah.
So can you guess what are the foreign keys are available in the fact table at this particular point of time, and along with the fact tables, along with the foreign keys, okay, so what are the key figures that the fact table contains?
It will be employee ID or student ID
Okay.
Employee, whatever table you said, like the time dimension is like maybe the date of
Calendar.
joining,
Okay.
yeah, calendar
Okay.
date of joining or something, and then the employee information, like other information, like his grade or whatever it is. And,
Okay. Malvika, can you guess anything else?
Anything else about what?
I mean, what exactly the fact table contains? I mean, I have 4 dimension tables, and now I just
Are
wanted
you showing
to.
something on your screen? Because I don't see anything on
Actually,
your
it is not.
screen.
No, Malvika. Actually, this is a total example only. That's it.
Oh, okay.
My question is, I just wanted to define a join condition between the dimension table to the fact table. Okay, I have 4 dimension tables and I have 1 fact table. Now, I just wanted to define a join condition between the dimension table to fact table. So, how can I define a join condition?
Okay.
Okay, I will explain you. I think you are aware of this database concepts, right?
See, fact table can have like customer ID, product ID, material ID, quantity sold, margin, and sales revenue and all that, right?
Correct. Yes. Yeah, that's
and
what
then dimension table will be like material. So these you can join to materials. I mean material name, and those customer ID, customer name, customer address.
Right. Yes. Let me explain. Right. Correct. Whatever you are saying. So, like for example, we have we have chosen like 4 dimension tables: employee dimension, okay, product dimension, student dimension, as well as the time dimension tables. Now, I just wanted to define I just wanted to create a fact table, and I just wanted to define a join condition between the dimension table to the fact table. Now, as you know that, like a fact table contains the foreign keys. Along with the foreign keys, fact table contains the key figures, like total measure values from all the dimension tables. Like at the time of define, so what exactly the foreign key? Foreign key is nothing but it just like it is a reference of that particular individual dimension table. For example, I have an employee dimension table is there. So employee dimension table contains the employee ID as a primary key. The same employee ID primary key is converted as a foreign key in the fact table area, and which is nothing but this is the reference of that particular employee dimension. Like while defining the join condition between the dimension table to the fact table, we used to define a join condition with the help of a primary key which is available in the dimension table as well as foreign key which is available in the fact table area. Okay, and along with this, so employee ID primary foreign key is available, and then student ID foreign key is available in the fact table, and then time dimension, that is the calendar ID, is available in the fact table area, and after that product ID. Product ID is also one of the primary key in the dimension table. The same primary key is converted as a foreign key in the fact table. Product ID is a primary key in the dimension table area. Okay, the same primary key is converted as a foreign key in the fact table. Right. Along with these 4 keys, fact table contains the what we call measure values from all the dimensions. Like measure is coming from one particular measure value is coming from the employee, that is the employee salary. Okay, and after that the student marks and the quantity sold. And along with this foreign keys, we have the 3 other key figures like measure values. One is the product like quantity sold, employee salary, as well as the student marks. Like while defining the join condition, so how we are going to define the join condition between the dimension, all the dimension table to the fact table area. So that means you need to place this fact table in the middle of the what we call a page. Okay, and you need to place all the dimensions. Okay, all the dimensions just around this particular fact table area, and after that, based on the requirement, you need to define a join condition between the individual dimension table to the fact table area. That means from employee ID dimension to employee ID primary key to employee ID foreign key, and student ID primary key to student ID foreign key, product ID dimension table to product ID foreign key, as well as calendar ID dimension to calendar ID foreign key. That means one fact table is surrounded by the multiple dimension tables. One fact table is surrounded by the multiple dimension tables. I'm sorry, actually, I have one PPT is there, but unfortunately that PPT is not. I missed that PPT. Like, it will show you. It will provide the total entity and what you call scenario. How exactly the fact table? What exactly the fact table contains? What is the what you call foreign dimension table contains? How exactly we are going to prepare the what you call the star schema? Okay, so all these things. Anyhow, tomorrow, most probably tomorrow, I will provide it to you. Okay, now, so here the concept is, so what you call the star schema. Star schema is nothing but one fact table. XYZ fact table is surrounded by multiple dimension tables. Surrounded by multiple dimension tables. Here we have 4 dimensions. Employee dimension. It's fact table is surrounded by the employee dimension. Okay, productive dimension, student dimension, as well as in time dimension. And after placing all these 4 different dimensions across, around the fact table, and we need to define a joint condition between the dimension table to the all the dimension table to the foreign key, fact table area. Okay, so this is nothing but a star schema. Star schema is nothing but one fact table is surrounded by the multiple dimension tables. Okay, and in real-time scenarios, most of the time we are going to design our we are going to design our universe. Okay, so with the help of this, what we call with the help of this star schema only. So most of the time we are going to prepare the star schema. Okay, so star schema is nothing but it is one fact table is surrounded by the multiple dimension tables. Okay, this is what. Any questions? Is this clear, Venkat and Lalita, Malvika?
Yeah.
Lalita and Malvika.
Yes, I'm good.
Yeah, this is clear.
Okay. And now, actually, we have one more concept that is little bit confused, but anyhow, tomorrow I will show you everything PPT. So how exactly the snowflake schema is, how we are going to the snowflake schema. Actually, snowflake schema is nothing but, again, one fact table is surrounded by the multiple dimensions. Again, the dimension table is further split into more detailed way. Okay, star schema is nothing but just listen. Star schema is nothing but one fact table is surrounded by the multiple dimensions. That's it. In the star schema level, we are not going to split the split the dimension table into the more detailed way. We are not going to split it. But coming to the snowflake schema, so with the help of this snowflake schema, again the one fact table is surrounded by the multiple dimensions, and again the dimension table is further divided into more detailed dimension way. For example, just assume that I have a region, I have a what we call the geographical structure. The geographical structure contains the country, region, okay, country, region, state, city, etc., etc. So this particular kind of geographical dimension table is further divided into country-wise, country table, and country table is divided into region table. Region table is divided into city table, or say state table. State table is further divided into city table. That means one parent dimension table is further divided into n number of child dimension tables. One dimension table is further divided into more detailed dimension tables. That is nothing but a snowflake schema. Again, the concept is same. One fact table is surrounded by the multiple dimensions, but coming to the snowflake schema, actually we are following the same thing, but the thing is that the particular dimension table is further divided into more detailed way. So that is nothing but a snowflake. So star is nothing but one fact table is surrounded by the multiple dimensions. That means the particular dimension table will not, we are not going to split that particular dimension into the more detailed way. Okay, but coming to the snowflakes, so we are going to split that particular dimension into the more detailed way. That is nothing but a snowflake schema. Okay, very simple. Again, I am repeating, star schema is nothing but one fact table is surrounded by the multiple dimension tables. And in this scenario, we are not going to split the dimensions into the more detailed way. That is the first point. Now coming to the snowflake schema, again Snowflake schema is nothing but, again, one fact table is surrounded by the multiple dimension tables. That is the first point. And the next one is that the dimension table is further divided into more detailed detailed dimension table. That is nothing but a Snowflake schema. Okay, in real-time scenarios, actually we are following the star schemas only. We are not going to follow the what we call the Snowflake schemas. One more important thing is that why we are dividing the parent dimension into the multiple child dimension, because for the hierarchical structure purpose. What we are going to do is we are splitting down the. We are dividing the parent dimension into the multiple child dimension tables. Okay, so this is nothing but a star schema as well as a Snowflake schema. Okay, any questions? Malvika, Lalita, Venkat, any questions?
No.
No.
Malvika? Yeah, Lalita, okay. And yeah, next concept is, actually these are all the data warehousing concepts. Okay, let me explain through PPT. Okay. Okay. One second.
Hey Ram.
Yes, please.
Yeah, could you please tell me, like, in real time when we are at the work, like, what are we going to do with these star schema and Snowflake schema? Are we going to create these things on our own, or it will be there in the system, or why are you
actually? Yeah. Actually, thing is that actually these are all the basic concepts, sir. So that's the reason actually here I am providing. Actually, these things are taken care by the data modelers.
Right.
Okay. We are not the responsible person, but as a technical person, we should know each and everything. So that's the reason actually here I am covering for the first 2 days of time. Actually, here I am covering the basic things. Okay.
Okay. Got it.
And we are not the, to be frank, we are not the responsible person to create the star schemas as well as the Snowflake schema, and we are not the what we call the authorized persons, and we are not the that much. We are not the eligible persons or capable person to create these star schemas as well as the Snowflakes. And
okay,
only data modelers actually they will take care of these things. Yes, please.
No, but I'm just wondering, like, do you think we will be resolving loops and traps and everything while doing that?
Yeah, that is a part of universe, right? That is a part of it. At the time of universe design, so as a universe designer, you should take care of each and everything. Like, as I told you that in the demonstration, as I told you that if whenever you are trying to design a universe on top of SAP, so then at that particular point of time, you don't need to resolve the loops, or you don't need to work with the tables, or you don't need to define the join conditions, cardinalities, okay, etc. So why? Because
no. My point is, to do that, do we need to know these Snowflake schema and the star schema? Do we have to know that? Does that have any relationship with those? That's what I'm asking.
No. It's not like that.
Okay.
That is a separate one. Okay.
Okay.
Yeah, I will explain you one things. Don't worry. I will give you one by one step. Okay. And here, if you observe, I will forward this material to you. So here I explain like what exactly the foreign key is, and so here if you observe, okay, like here we have a employee table as well as a department table. So employee table contains the associate ID, first name, last name, and department number. And here I just wanted to define a joint condition between these two different tables with the help of a department number. So department number, employee.department number is equal to department.department number. So whenever this condition is passed, then only you will receive the exact results. Okay, I will explain you one by one. And here schema and Snowflake schema, that maybe that is in some other PPT. Okay, so in this PPT actually here I explained what exactly this database and what type of database models are available, okay, in our real-time scenarios. Okay, dimensional modeling system. Actually we are using in the data warehousing level, we are using this DM model, dimensional modeling concepts. Okay, and what is the table and what is the index and what is the primary key and what is the foreign key and etc. etc. So here I explained each and everything. Anyhow, I will provide it to you. Okay, so just now actually we discussed about the star schema as well as the snowflakes, and as I told you that we are not the right persons, and we are not the we are not the responsible person to create this star schemas as well as the snowflake schemas. Only the data modelers, they will take care of these things. Okay, but as a technical person, as a data warehousing technician, we should understand what is the data, what you call the star schema and what is the snowflake schema, how to prepare the star schemas as well as the snowflake schema. So that's the reason actually here I explain things. And the next one is we have one concept called slowly changing dimension. What exactly the slowly changing dimension? This is also the ETL part, but here I am explaining. Slowly changing dimension, in short form we call it as a SED. Actually, in real-time scenarios, we have nearly 6 different SEDs are available. Slowly changing dimensions are available. But in our real-time scenarios, in our projects, we are using only 3 types of slowly changing dimensions. First level slowly changing dimension, that is the type 1 SED, type 2 SED, type 3 SED. Type 1 slowly changing dimension, type 2 slowly changing dimension, and type 3 slowly changing dimension. What exactly is a slowly changing dimension? So slowly changing dimension means it captures the, in real-time scenarios, it will capture the changes over the period of time. Like for example, just assume, coming to the first level slowly changing dimension, I will explain you one by one. So I have, as I told you that in the last class, as I told you, I explained with what we call the source database as well as the target database. In real-time scenarios, we will have 2 types of databases. One is the customer database, that is the source database, and the target database, which we are having in our own environment. So type 1 slowly changing dimension means it captures only the updated information only. For example, today, just assume that yesterday, November 31st, I made one transaction. Just assume that I made a transaction on November 31st. Okay, so that record is available at this particular point of time. That record is available in my database. Okay. Now today, again, I just wanted to. Today also I'm going to. Complete one more transaction today. So at this particular point of time, the old record will be removed and a new record will be inserted into the database level. That is nothing but a first level slowly changing dimension. Very simple. So last evening I made one transaction. So right at this particular point of time, if I observe that particular history, so I will get the transaction on November 31st to so and so time. Now today also I just wanted to today also I'm going to prepare. I'm going to do one more transaction. Okay, at 10 o'clock or 11 o'clock. So after 11 o'clock, you will receive the new transaction in your database. That means the old transaction will be replaced with the new transaction. That means at this particular point of time, so here at this particular point of time, you will get only the updated information only. So there is no historical information is available. No historical information is available. That is nothing but a slowly changing dimension 1. That is the type 1 slowly changing dimension. So that means only updated information is available in our database. So there is no point of historical data. There is no, we will not receive any historical data in the database level. You will get only the updated information in your database. So that is nothing but a type 1 slowly changing dimension. Is this clear, Malvika, Lalita, Venkat?
Yes.
Venkat, are you there?
Yeah, one question to you.
Yeah.
Yesterday you made a transaction and today you make another transaction. So what happens to the yesterday's transaction, that goes and sits in the second record, or is
No,
it
no, no, it's
overwritten?
not second record. So you will not get any old record in this at this particular point of time. You will get the new transaction in your system. That's it. So there is no concept of, there is no chance to get the historical data in other form. Actually, we are in the right track right now. So at this particular point of time, you will not get any historical information. You will get total updated data in your local system, in your system. That's it. That is a level one, what we call level one in a type 1 slowly changing dimension. Okay, just like in our last example, we discussed about the transactional database, right? Transactional processing system. So transactional processing system does not contain any historical data. It contains only the most updated information only. So that is nothing but a slowly changing dimension. Type 1 slowly changing dimension. Clear, Venkat?
Yeah, clear. Yeah.
So the source itself does not have the source itself does not have the transaction.
No. Here, don't get confused. Actually, where we are inserting the new table, new record. We are inserting the new record in the target system in our own environment from the source to target. Anyhow, source system contains the total historical data. But at this particular point of time, we are working on the target database, right? So we are loading the data into the target system. So at the time of loading the target system, so the old transaction will be, replaced with a new transaction. We are talking about the target database level, ETL target database. Okay. Now coming to the second one, type 2 slowly changing dimension. Type 2 slowly changing dimension contains both historical information as well as the most updated data. For example, just assume, last evening I made a transaction. So just assume that it's in the last 4 to 5 years. So I am using my account, and every month and every day, so I'm doing some transactions. So in the last evening also I did something. Okay, so at this particular point of time, so I have a total historical data since the last 4 years to till date. And today, for example, just assume that I'm going to do one more transaction on 1st December 2013. So after completion of this transaction, you will receive a new record. You will receive a new record with a name, with a timestamp of 1st December 2013, 10 a.m. IST. That means at this particular point of time, your database contains total historical data as well as whenever a new record is arrived, it will accept that particular new record. That means at this particular point of time, the database contains the total historical information along with that historical information. So here you will receive you will get the updated data. But that means the type 2 slowly changing dimension, with the help of this type 2 slowly changing dimension, you will get the total historical data as well as the most updated data. So it contains both the things, historical information as well as the updated information. That is nothing but a type 2 slowly changing dimension. So whenever a new record arrives, it will accept that particular new record. Okay, so that means the new record will be inserted into the target system. So at that particular point of time, so if you observe that particular database, so the database contains the total historical data as well as the new record, so updated information. That is nothing but a type 2 slowly changing dimension. Type 1 means only updated data. Type 2 means both historical data as well as the updated data. Okay, clear, Venkat, Lalita and Malvika?
Yeah.
Yes.
Lalita?
Yeah, it's clear.
Okay. Now the last one is type 3 slowly changing dimension. Type 3 SED. Type 3 SED contains partial history, and it will contain the partial history plus updated information. Partial history. For example, in our just assume our databases, organization database. Maximum the organization people, okay, they will maintain the databases like last 6 months of data and the last for 1 year of data. So that means just assume that So from December 1st onwards, like first before, like just assume that, so they are maintaining the records for the last 1 year. So today is the 1st December 2013. So you will receive the data. You will get the, if you, at this particular point of time, you will get the data from 1st December 2012 to 1st December 2013. Okay, and after that, if you like tomorrow, 2nd December 2013, if you observe the records tomorrow, so at that particular point of time, you will get the data from the 2nd December 2012 to 2nd December 2013. That means they will fix one particular period. So within that period only you will receive the data. Within that period, it means within that particular time period only you will receive the data. If they are maintaining the structure, or if they are going to maintain the structure since the last 1 year or 2 years of time, so last date to date. That means last whatever the date to date. So that is the 1st December 2013. So you will receive the data from 1st December 2012 to 1st December 2013, 1 year data. And if you move to the 2nd December 2013, at that particular point of time, you will receive the data from 2nd December 2012 to 2nd December 2013. That means we are getting only the partial history only. We are not getting the total historical data, right? For example, just assume that I opened my bank account in the year 2012 or 2002, for example. Okay, from 2002 to 2013. So if you are getting the total historical data, that is nothing but a slowly changing dimension 2. That is the type 2 slowly changing dimension. Okay. So at this particular point of time, if you request the banking people, so the people, they will provide you the total historical data from 2002. 2002 account open date is, for example, 1st January 2012. So 2002, you will receive the data from 1st January 2002 to 1st January 2002 to till date. So that is nothing but a type 2 slowly changing dimension. Now here we are talking about the type 3 slowly changing dimension. Type 3 slowly changing dimension contains only the, it will contains only the partial history and updated information. Partial history means at this particular point of time, so they will not provide you the total 10 years of data or 12 years of data. They will provide you only last 1 year transactions or last 6 months transactions only. That means they will allow you to get only the last 6 months transactions or last 1 month transaction. That's it. Okay. So this is nothing but a slowly changing dimension 3, type 3 slowly changing dimension. Okay. Very simple, madam. Like type 1 contains only historical data. Type 2 contains both historical as well as the most updated data, and type 3 contains partial history and updated information. That's it. Clear? Is this clear? All of you, Lalita, Malika, and Venkat.
Yeah, it's clear.
Yeah, this is clear.
Malika, any questions?
No, I'm.
Okay, Lalita, any questions?
Yeah, this is clear.
So this is about the slowly changing dimension, and to be frank, actually we have nearly 6 different slowly changing dimensions, but we are following only the first 3 only, type 1, type 2 and type 3. Okay, and yeah, tomorrow onwards we'll start our basic, business objects part, total business objects part.